Right. In today's lecture, we'll talk about, it's a continuation of the set theory, and today we'll talk about complement set. Now, complement, unlike the way it actually means in language, in set theory, in actual fact, means elements that are not found in the set. For instance, if we had a set A that was like this, our set A was, say, 1, 2, 3, 4, 5. And for us to talk about a complement of a set, we need to have the universal set. Let us say the universal set was the set of whole numbers up to 10. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, like that. That represented our universal set. Now, the complements of set A would be members that are not found in set A, but are found in the universal set. So A complement, we use that symbol in mathematics, A complement would be that set. So the elements that are not found in set A are 0, 6, 7, 8, 9, 10. So that would be A complement. A complement meaning elements that are not found in set A. Now, from here then, it's about time I introduced what is called the Venn diagram. Now, the Venn diagram is a very important concept in set theory. The Venn diagram is basically a diagrammatic representation of sets. So we represent sets this time in diagram form. And when that is done, it's either, it can be represented as a square and circles inside the square, and that is regarded as a Venn diagram. So a Venn diagram is drawn like this. And the rectangle itself would represent the universal set. So that would probably be our Q. The Venn diagram, therefore, would represent our Q, which is the universal set. So the elements of A, so I would have A like that, with the elements 1, 2, 3, 4, and 5 in it. Now, and would write our set A here. Now, since we have represented A in there are elements that are in Q, the universal set, that are not in A. And those elements would be represented outside A. And therefore, this would be 0, 6, 7, 8, 9, 10. And we always use dots to represent the elements, because if we just left it like that, this would be the same as 1 and 0. So to represent 10 as a single element and not a combination of a 1 and a 0, we use the dot in set theory. So that is the universal set. Now, within the universal set, we can have other sets as well. For instance, if let us say we had set B, which had 1, 6, 8, 11. We cannot include 11 because if set B is a subset of the universal set, it should not have an element that is not in the universal set. So let us say our set B, therefore, was 1, 6, and 8. Then we can redraw our universal set and represent that in the universal set in this form. We'd have our Q, the universal set. Now, because there are elements in set A, let's bring down our set, because there are elements in set A that are also in set B, which is 1, it is better for us to have an intersection. So we would therefore have set A intersecting with set B. That would be our A. That would be our B. Within the intersection, what element is in there? 1, because 1 is found in both A and B. Then we now write down the elements that are not in there but are found in A. They are not in the intersection but are found in A, which would be 2, 3, 4, and 5. Then in B, the elements that are not in the intersection but are found in B are 6 and 8. So then we need to continue stating that the universal set has more elements than those that are in A and B, and the ones that are left out are 7, 9. Again, you can write them anywhere as long as they're within the universal set. 10 and 0. That is now our representation of the set in the Venn diagram. Let's then have a quick recap of what we've talked about today. We've talked about the universal set, and we've talked about the intersection of sets as well as the union of the sets. Now let's start from the beginning. If we had the set, say, A, that was represented like that, our set A being 1, 2, 3, 4, and 5, and we also had our set B being 4, 5, 6, and 7, and our universal set Q, which is 1, 2, 3, 4, up to 9, we can find the intersection of, say, set A intersection set B. What would that be? These would be the elements that are found in both A and B, and these are 4 and 5. We can see there's 4 and 5 there, 4 and 5 there. Therefore, A intersection B would be 4 and 5. What about a union? The union of the set means putting the sets together. So we're going to unite the elements in set A together with the elements in set B. So the union of A union B would be elements in set A would be 1, 2, 3, 4, 5. Unite them with elements in set B. This would be, we already have 4 and 5, so the remainder would be 6 and 7. So that set represents the union of set A and B. Now, we can also now have a diagrammatic representation of this, which is the Venn diagram. So within our Venn diagram, therefore, we would draw the rectangle, and represent the elements in their sets. So there is an intersection. We've already seen that there is an intersection. So our sets are going to intersect. We have Q, our universal set. Within the intersection, and let's call this A and that B. The intersection of A and B was 4 and 5. What is left outside A is 1, 2, and 3. And what is left outside the intersection in B is 6 and 7. But there are also elements in the universal set that are not covered there, which would be outside the sets A and B, and this would be 9. Is there any other element? In actual fact, if we look at our universal set, we can see that 8 is an element that is supposed to be in our Venn diagram. So therefore, since 8 is not in A or B, it should also be there. So we have our element 8 as well. Therefore, if we're asked how many elements are not in set A and B, but are in the universal set, it would be 9 and 8. Several questions can be asked from this, from the Venn diagram. In other words, a Venn diagram is a diagrammatic representation of sets. Now, the questions that might be asked would be, how many elements are in the intersection of A and B? Without knowing where A and B is as a set, we can look at the diagrammatic representation and we can see the intersection here and be able to answer that there are 2 elements in the intersection of A and B. But the question was how many elements are in the intersection, and these are 2. But if it was list the set that represents the intersection of A and B, that would be now written as A intersection B, and this would be equal to 4 and 5, like that. But if we're just asked how many elements are there, we can see there are 2. We may also be asked how many elements are found in set B only, but not in A. So the elements that are just found in set B would be 6 and 7. We may also be asked how many elements are found in set A only and not in set B. And the elements that are found in set A only and not in set B would be 1, 2, and 3. Now, remember we talked about complement of a set. Now, let us say we're now this time asked, what is a complement? In other words, which elements are in the universal set but are not in the set A? And these would be all the elements in the universal set without the set A itself. So these would be the sets 6, 7, 8, and 9. This would be A complement. We can see that these elements do not belong to the set A. We may also be asked, what about B complement? B complement would be the elements that are not found in B. Which ones are these? These would be 1, 2, and 3, and what else? 8 and 9. These are elements in the universal set as well as A, but are not found in B. So that would be B complement. Now, these questions can get a bit complicated. In other words, not complicated really, but rather sophisticated. We could have find A complement intersection B complement. In other words, find the intersection set of the elements that are not found in A together with the elements that are not found in B. So we can only do that if we have the two complements. So we need to have the complement of set A and the complement of set B. The intersection of those, therefore, if we look at that, we can see that the intersection are the elements that are common in there, which would be 8 and 9. So the intersection of A complement, intersection B complement, is set 8 and set 9. Now, for us to answer questions on complement, what I always tell students is that it's important for, first of all, for you to know your set first. So know your set. Complement means elements that are not found in that set. So in this case, you have your set, then you look for elements that are not in that set, which are in the universal set. So list your set, then look for elements that are not in the set, but are in the universal set. We may be asked to find the complement, the union of the complements. So what is A complement union B complement? In other words, the elements that are not in A, unite them together with the elements that are not in B. So A complement union B complement would have all the elements in A, which would be, it's better to start probably with the elements not in B, which is 1, 2, 3. So it would be 1, 2, 3. Do we have 4? No. 5? No. 6, 7, 8, and 9. So this would be A complement union B. I have united all the elements in the complement of A together with all the elements in the complement of B. So that gives me A complement union B complement. So from the universal set, therefore, which is our set there are so many questions that can be drawn. There are so many questions that can be asked and answered from the universal set. Now, at foundation phase, you are not going to be teaching this, but you need to know what set theory is, because you will be dealing with sets. In other words, you talk about the sets of numbers, whole numbers, the set of natural numbers, the set of even numbers, the set of integers. All your teachings in foundation phase revolves around sets. Sets of children that are standing up, sets of children that are sitting down. So when you are dealing with counting, you are in actual fact essentially dealing with sets. Count for me, you ask a child, for instance, to count for you from 0 to 10. That's a set that you are dealing with. The child is going to count. Count for me backwards from 9 to 1. That's a set that you are giving a child to recite to you. So we'll be dealing with sets and set theory. So your understanding of this theory is very critical.